Welcome to Chade Hydrogen Podcast.
Four electrolyzer technologies, one market heading toward 275 billion euros, and the race that will decide who is the hydrogen economy for the next 2 decades. I'm Daniel Chade. Welcome to the Chade Hydrogen Podcast. Today, we get into the real contest between these technologies, and we will show what the data actually says about who's winning. Let me start with three numbers worth holding on to. The first, 275 billion euros. That's roughly where the global green hydrogen market is heading by 2030. The second, 8%. That's the annual cost reduction the industry is targeting, which means the economics keep improving and the window to get early keeps narrowing. And the third, 40 gigawatts. That's the electrolyzer capacity, and the EU alone is aiming for this decade. Here is why this matters to you. Whichever electrolyzer technology your organization chooses today will shape your cost base, your supply chain resilience, and your competitive position for the next 15 to 20 years. Four technologies are competing for that future, and each carries a very different risk and reward profile. Over the next several minutes, we will look at what the data actually shows. Before we get into the numbers, let me introduce the four players. First, Alkaline, the veteran. Decades of industrial use, the lowest capital cost, and the proven supply chain. It's fully commercial. TRL9, the catch? It's slower to respond to variable power, and that matters when you're pairing with renewables. Second, PEM, the challenger. Fast responding and efficient. A natural fit for wind and solar. The trade-off is higher capital cost and the reliance on platinum and iridium. And that's a supply chain and geopolitical question, not just a technical one. Third, AEM, the dark horse. No precious metals and a promising cost path, but it's still early. TRL 5 to 7, higher risk, potentially high reward. And fourth, SOEC, the specialist. Outstanding efficiency. But really, only when you've got industrial waste heat on hand. More complex to run, so not for everyone. But for the right side, it's transformative. Let's look at the data, but metric by metric, not by the technology type. Start with efficiency. SOEC stands out here, 90%, well ahead of the rest. But that figure assumes waste heat is available. Without it, efficiency drops a lot. Current density next. PEM leads clearly, and that's exactly why it handles variable power so well. Alkaline is lower, and AEM sits in between and improving. Now, durability. This is Alkaline's strong suit, 80 to 100,000 hours. PEM is catching up. AEM is the question mark at 20 to 50,000, and SOEC is around 40,000. That is especially important when you're planning 20-year asset lives. Durability is a really key metric here. And finally, CapEx. And it's worth splitting the stack from the full system. On stack cost, Alkaline runs 250 to 450 euros per kilowatt. PEM, 350 to 600. SOEC, 680 to 1600. Add the full system and everything climbs. Alkaline lands at 700 to 1050. PEM at 850 to 1375. And SOEC is the priciest, 1,700 to 4,300. AEM, we don't have reliable commercial data yet, and that gap itself is worth noting. Let's translate all of that into cost. A quick note on what this number means. This is production-only cost of hydrogen measured right at the electrolyzer output. It excludes compression, purification, and storage. And we're looking at two electricity scenarios. The EU average renewable contract at around 55 euros a megawatt hour, and the cheapest Iberian solar contracts, around 30 euros as on the third quarter of 2025. Alkaline lines around 4.80 euros a kilogram on average EU power, down to about 4 euros with cheapest solar. That makes it sensible default for large baseload projects today. PEM is a little higher, roughly 5 euros 40 and 4 euros 50 on the best solar. That reflects its higher capital cost and precious metals, but its fast response make it the best pick for variable renewables, and that gap should narrow meaningfully by 2027 to 2028 as manufacturing scales. Now, SOEC, and here is the interesting reversal. It has highest system capital cost of all of the four, but when you've got high temperature waste heat or steam available, it reaches the lowest cost of hydrogen of any of the technologies. About 3 euros 80 on average power, 3 euros on the best solar. The heat substitutes for electricity, and electricity is most of your cost. AEM is at the early end of the curve. It belongs in the comparison, but the information provided is indicative. Roughly 5 euros a kilogram modeled at pilot scale. If membrane's durability reaches 40,000 hours, those numbers will drop a lot. For context, the EU and International Energy Agency IEA target is somewhere around 1.5 to 2 euros a kilogram by 2030. We're not there yet, but the gap is closing faster than most of the people expect. A good technology choice isn't only about the upsides, it's about knowing what can go wrong and whether there is a credible plan for it. So, let's run through each. Alkaline. The main risks are handling the potassium hydroxide electrolyte and the slow dynamic response. Both are manageable. There are well-established safety procedures, and you can use battery buffering to smooth the response. These are known, solved problems. PEM. The risks here are more strategic. Platinum and iridium are critical materials with concentrated supply, and membranes are costly. The fixes are real: lower catalyst loading, recycling, supplier diversification, but they need active management, not assumption. AEM, the honest answer is we don't fully know yet. Durability is unproven at scale, and the track record is thin, so treat it as stage pilot first investment. Think of it as R&D spent, not infrastructure spent. And SOEC, the challenges here are mostly thermal, high temperatures, thermal cycling, heat integration. These are solvable engineering problems, especially when you can collocate with industry. The question I get asked more often is simple: which technology should we choose? And the honest answer is, it depends on what you're building and where. If you're running large-scale baseload production above 100 megawatts, alkaline is your strongest option today, on both scale readiness and cost. If you're pairing with variable renewables, offshore wind, utility-scale solar, PEM, fast response make it the clear choice. Alkaline simply can't follow the load curve so well. For decentralized or distributed sites, PEM and AEM both score well, and AEM could be transformative here if it matures. Industrial waste heat integration? That's where SOEC shines. Nothing else comes close. And on long-term cost leadership, AEM is outstanding. If it delivers its promise, it has the potential to flip the industry's cost curves upside down. So the table doesn't show you one winner, it gives you a map. And reading the map well for your own context is where the value lies. Now, let's talk who's actually building this at scale. Alkaline, Nel, ThyssenKrupp, John Cochrane, McFire. Industrial-grade players with real installed capacity. This is a major industry, not a startup bet. PEM, ITM Power, Plug Power, Siemens Energy Cummins. When names like Siemens and Cummins are real, the technology has crossed a credibility line that matters to boards and procurement teams. AEM and Apter is the one to watch alongside Elogen, now part of Air Liquide and a growing number of startups. The ecosystem is forming, but it's earlier stage. SOEC, Topso, Bloom Energy, Elcogen, Ceres Power, Solidera. Serious companies with serious backing, though production volumes are still low. And here is the headline: Alkaline still holds most of the installed capacity today, roughly 2/3, and is likely to keep the largest share mix to 2030. But PEM slice is growing steadily, driven by renewables. The mix is shifting, and just not as abruptly as some headlines suggest. Now, let's put the 4 through a simple scorecard. 6 criteria that matter when you're making a capital decision. Technology readiness weighted at 25%. Alkaline scores 95, PEM 85. Both technologies are proven. AEM 55 and SOEC 65. Those are still maturing. Current capex 20%. Alkaline leads at 90, PEM at 60, with AEM and SOEC marked down for higher or uncertain costs. Efficiency 20%. SOEC breaks away at 95 with appropriate thermal conditions. PEM at 80, alkaline and AEM around 70. Scalability to 2030, 15%. Alkaline and PEM score highest. AEM and SOEC face real scale-up challenges in this window. Supply chain risk, 10%. Alkaline is strong. PEM is marked down for its critical materials, and AEM is relatively well placed. No precious metals is a real advantage. And future cost 10%. AEM leads at 90, PEM at 85. This is where the long-term game is played. Weighted totals: alkaline 85, PEM 76, AEM 62, SOEC 61. But the numbers only point a direction. Context fills the rest. So let's put everything together into clear summary. For most organizations entering hydrogen market between now and 2028, the leading bet is alkaline at scale. Proven, major supply chain, lowest capital cost. If you need to produce commercially today, that's your rational foundation. In parallel, build PEM capability is the technology of choice for variable renewables, with cost parity expected around 2027 to 2028. And if you wait for confirmation, you will have already missed the supply chain positioning window. Watch closely AEM. It has the best long-term cost potential from all of the 4, and membrane durability is key here. If it reliably works for 40,000 hours at commercial scale, the whole landscape shifts. That's a scenario to prepare for, not just monitor. And treat SOEC as a strong niche play. It's exceptionally efficient where high temperature waste heat or steam exists. Evaluate it seriously for right application, but don't force it where the conditions aren't there. And the big point underneath of all of it: no single technology wins everything. The smartest organizations aren't placing one bet, they are building a portfolio. Let me give you a sense of how this plays out over the next few years. Right now, in the second quarter of 2026, the race is well underway. It's been running for a while. Alkaline is dominant, PEM is closing fast, and the companies scaling today are locking in supply chains, talent, and intellectual property that get expensive to replicate later. By the second half of 2026, PEM approaches cost parity with alkaline in more applications, and the first AEM pilot results start coming in. Results that will either validate AEM's commercial future or show real depth on it. Through 2027, AEM's membrane durability data becomes the single most important number in the sector. Good results invite a new wave of investment. Weak ones probably pushes AEM into a later decade. And by 2028 and beyond, the market consolidates. The winner lock in their positions across supply chains, IP, and cost curves. Organizations that haven't made their bets by then aren't just late. They risk being locked out, which brings me to 3 questions worth talking into your next strategy meeting. First, which electrolyzer technology does your current roadmap assume, and is that assumption still valid given what you've heard today? Second, are you exposed to critical material risk, iridium, platinum, that a different technology choice could remove? And third, do you have the in-house expertise to weigh these trade-offs adequately? Or would you need an independent partner help? Navigating this alone is expensive, not because the technology is too hard to follow, you've just followed it, but because the cost of the wrong bet, the wrong timing, or the wrong vendor is measured in millions of euros, years of lost time and missed business opportunities. That's what Chade Hydrogen does. We provide independent, technical, and strategic advisory for exactly these kinds of decisions. No vendor relationships, no conflict of interest, just 15 years inside hydrogen startups, R&D teams, and scale-up programs applied to your specific situation. So if something today raises a question you would like to explore, or you're facing a decision that needs advisory, visit chadehydrogen.com or email me directly at daniel@chadehydrogen.com. Thank you for listening, and remember, the winner isn't the technology with the best spec sheet. It's the organization that acts on the right information at the right time. Until next time.
Chade Hydrogen says bye-bye.